Hello, this is part 2 of chapter 3, and we're going to continue our lecture from here on slide 22. The slide is available up on Blackboard if you want to look there. Concepts that we're going to cover are abstraction, modularization, classes define, types, class diagram, object diagram, etc. Object interaction. Two objects interact when one object calls a method on another. So a concept we're going to get to in a couple weeks is good designs and things like that. But what they like to talk about is typically one object calls into another object. That object serves information. The client asking for the information or the object asking for the information is called the client. It's a common model of how to talk, but basically if you think about it, one calls the other, so one relies on the other to get its information. Client objects can ask the server object to do something. So in other words, I can call into something else and ask it to do something. In the case of this, we're going to be doing some extra stuff, but think of it like this. I have an object. I'm going to ask another object in memory to do something on my behalf. It's a way of simplifying and following the principles of this chapter's discussion. The client object can ask for data from the server object. Typically, the server object does not call into the client object. So in other words, relationships tend to be one direction or unidirectional. A will call to B. A will get data from B. A will do everything it wants on B, but B typically does not call back to A for anything. When you do that, you ruin some of the paradigms of good design, and you want to avoid that whenever possible. Two number display objects store data on behalf of the clock display object. Clock display is the client in this particular case, and the number display is the server. In other words, the number display holds all the information that clock display wants to get. The client calls methods in the server object, okay? And again, clock display is calling into number display. In this case, method calling, we have something called time tick. It increments minutes.increment, so it's calling into the minutes object. Get value equals 0, time to roll it over, update to display. Alright, so this is very straightforward, nothing overly complicated. External method calls. Alright, so there's two kinds of method calls that we're going to talk about, external and internal. This is the first type, which is external. External, you typically have to, well not typically, always have to specify the object name that you're going to call into, dot the method names. Okay, so examples down below is hours.increment, minutes.getValue. Remember that hours and minutes are relying on ultimately the same class but different objects. Okay? Internal method calls, in other words, you're calling something within the same class, you don't have to put a class identifier in front of it. So no variable name is required, update display. Internal methods are often have private visibility. In other words, they're for me, myself, and I don't want other classes to gain access to them if they're truly intended to be internal. I also call them helpers, where they're helping you get something done internally. You're not trying to have external people look at it. By using private, what does it do? Prevents them from being called by outside their class. Internal method example. Here we've got private update display. It doesn't return any value. It's void. Again, for me, my preference is I tend to return a 0 or a -1. Sometimes I'll return other values to let people know that something is happening. It's more of a way of debugging things later if you want to, but it's certainly not required. Display string equal hour.display value minutes.display value. So this internal method here is calling two external methods in hours and minutes. Okay? A method call on another object of the same type would also be an external call. So in other words, if number display were to call another number display, that would be an external call. Internal means truly this. So the other way to do it would be a this dot. Please don't do that. It's not necessary, and it's just going to add extra keystrokes that aren't necessary. External means any other object regardless of its type. Okay? So external meaning outside the current object. This keyword, we talked about it a little bit earlier. I think we even touched it in a different lecture. It's used to distinguish parameters of the same name. So in other words, typically when you have a setter, you pass in a value. Here it's used, this.limit refers to the object's version of this value, not the parameter that's being passed in. This is very common. Many IDEs that generate your getters for you, and your setters for that matter, will automatically put that stuff in there. It's the way to go. It avoids confusion and helps you out. All right, the debugger. The debugger is really cool. I'm going to record a separate discussion for the debugger and how to use it later. You can set breakpoints, look at variables, step through code, etc. So I'm not going to go into great detail now, but I will come back to it again in a separate discussion. Summary of the concepts. We talked about object creation and overloading, internal and external method calls, and debuggers. The debugger, again, is a separate lecture. Internal, external, we've talked about, where internal is within the same object, external is to external or other objects. We talked about overloading, we talked about object creation using the new. These are very fundamentally important concepts. They are important to everything you're going to do in Java. So if you don't understand this, please make sure that you reach out to me. Make sure that you go through the class textbooks, do the examples, and go from there. With that, that's the end of the Chapter 3, Part 2 presentation. If you have any questions, as always, reach out to me. Hopefully you got something out of this lecture and it was helpful.